Alrighty, guys, I've lectured for 10 minutes. We're on the chapter about loops, at least temporarily, which is chapter 8 of the online text, considerably ahead of where we are in the textbook. What I want you to do is take a look at what I've got here and type it in. So just pause the recording, type it in, and then I'm going to need to scroll down a little bit where there's 2 for loops. You know what, maybe I could get the for loops on here if I deleted all the spaces. Alright, there we go. Pause that, type it in, and then I'll continue the lecture. Yeah, if you accidentally typed in while 1 is less than 10, it'd be an infinite loop. The ability to get confused about what I've typed leads me to never use lowercase l as a variable name, so I'll always use uppercase L. However, I do tend to use I as an increment iterator. Alright, so we have a way of counting through a list here. Not that we see it yet, but you see this 0, 1, and 2? Whenever you see consecutive numbers like that, you think, oh, that's going to be a loop. We can get the list of the loop with the len keyword. So let's see if we can make a list that's all 3 of these things added together. Not a 2-dimensional list built like that, but I'm going to comment out this line, scores is equal to that, because that made a list of lists, and in this case I don't want that. So I'm going to comment that out and make a new one, which is scores is equal to S1 plus S2 plus S3. If I correctly recall, that's going to make a 1-dimensional list, which is 9 items long, because it's just appending 3 lists together. But why don't we print it out to make sure? So underneath that scores line, I'm going to do print scores. So that's the line that I just added. That's the line that I just added. Now run that and see if we get scores being 9 elements long. And why don't we put the name of that list first? Scores is equal to, end quote, comma scores. Just, because as we run these things, we wind up just printing out number after number after number, and it doesn't make as much sense. Okay, so we have a list of 9 scores here. That makes me happy. Why? Because I want to write something that will count through it and maybe add them all up. At the very least, print them out for our first run. So that's going to be element 0, that's going to be element 1, that's going to be element 2. So I is going to count from 0 out up to, what's the highest index it's going to hit? If this is 9, we're going to start at 0 and go up to, if we go up to 9, then what's going to happen? We're past the end of the list, and it's going to blow up. 0, 1, 2, 3, 4, 5, 6, 7, 8. So your iterator, your loop control variable, had better never get to the number of items. It needs to stop 1 before. So we could write a range statement that went from 0 to 10, and then I would always equal 0 to 9, so that I would count 0 through 8, which are valid indexes. But rather than hard code that 9, I'd rather just use the len command. All right, so I'm going to do that. Down here, for I in range, starting 0, and by the way, you can leave that 0, off. It defaults to starting at 0 anyways. Up to the length of the scores list. I didn't mean to put that parentheses there, sorry. There we go, length of scores. And then I have one more closing parentheses. Make sure you have 2 closing parentheses, because if you count over here, we really do have 2 openings. And let's print out I, our index value, and then scores at that index value. And hopefully when we run it, we'll see scores 0 through 8. Just confirm that, actually run it by the time it's done. Or after you've typed it all in. I'm going to test it out, make sure I don't have a typo. There we go. Okay, so it counted out elements 0 through 8, which is 9, because that's the length of the list. And when you use a range statement, it starts at 0 and it goes up to 1 before your terminating condition. So if I was going to call it out specifically, the first element in the list is at index, an element's what it's called, each item is called an element, is at index 0. The last element of the list is at n minus 1, where n equals the length of the list. Sorry for the techie explanation, but you understand that. If the length of the list is 10, then you're going to count 0 to 9. Any syntax errors? What if we wanted to add up the numbers in that list? Well, there's a shortcut way of doing this. That's all right. But what if we could rewrite the same thing like this? Tell me if you like this better. I'm going to use V for value now rather than I. In my head, I means index, but V means value. So for V, in scores, print V. That does the same thing. My bet is that you like that one better. Maybe not. It's totally cool. This is how you would do it old school in a lot of languages that did not support this syntax. This syntax works, with small variations in just about every programming language you can ever find. Now, a lot of the object-oriented languages support this as well. So C is not designed as an object-oriented language. It would use a syntax like this. C++ and Java allow you to do either. So what's the difference? Here, we are pulling out the element by specifying the index number. Here, the for loop is doing all that trouble for us. So it puts, the first element of the list in V so we can print it out, puts the second element in the list in V so we can print it out, and so forth. So it hides that stuff. The only problem is we don't have the index number if for some reason you wanted it. So when we run this, it's not going to print out the element and the index value. It's just going to print out the elements. Right, this printed out 0 and then the score, and then 1 in the score, and 2 in the score. This one's not going to have those numbers in front of it just because we don't have an index counter. Yeah, you could fake it. But if you did that, then you may as well just use that syntax. All right, there we go. See? Same idea. This time we printed out V, which is the value stored in that list. Only thing to really consider is that this is not the list element itself. It is a copy of it. Meaning that if you wanted to erase all the elements of the list or add one to them, you would not use this style. You would use that style. So let's write a loop that will add up all the values of the list together. The general style of processing is always, and you don't have to type this, initialize counters and accumulators, loop, processing the list, and then do something with the accumulator. Calculate the average or whatever. And an accumulator is just a variable, like total. So here we go. If we do it this style, I would need a counter variable, but the counter is actually initialized there. But the accumulator is not. If I do it this style, which is easier to type, so that's what I'm going to do, I still need to initialize the accumulator because you always have to have a variable before you can start adding things to it. So total is equal to 0. And then for every value in scores, total plus equals V. And I'm pretty sure we did this last week as well. But like I said, loops and lists are so important, I don't mind spending a lot of time on them. So now we can calculate the average. AVG is equal to total divided by the number of items in the list. Now I mentioned how you get the length of the list. How do you get the length of the list? If we scrolled up, we'd see it. LEN. Yeah, you use the LEN built-in function. The only drawback is The only drawback is that this would blow up if the length of the list is 0. And you actually can define a list of length 0, which we will do in a minute. So let's print out the average. Total equals %.2f, comma, average equals %.2f. And then after the end quote, we're going to put a percent sign, followed by a pair of parentheses and one last trailing parentheses. And inside this parentheses here, we're going to print out the two values that we want to fill into %f placeholders, which is total and an average. I bet the book uses the newer style, which is where you use dot format when you're printing stuff out.
I think it uses this stuff.
It uses this stuff? Great, great. I like this style because it's very similar to what you would use in C with your printf statements and in Java with your printf statements. But the newer style is cool. I just never remember it. Alrighty then. I goofed. I'm going to run it, show you the error, and I want you to tell me what I did wrong. Unindent does not match any outer indentation level.
So you have to bump it over because the 4.
I could bump it over and it would calculate the average each and every time. That's a totally good way of doing it, but I don't need to calculate the average each and every time. Instead, I need to unindent this one, and maybe that's what you really meant. Either way would work as a solution. That's fine, but you don't want to recalculate the average every single time. You can wait until you're all done. Now what happened is if for some reason I just had a space in front of my tabs.
I'm just supposed to change that. Yeah, should that say average sheet?
Yeah, I've goofed, thanks. That is AVG, so that had better be AVG. Fix that if you didn't already catch my error. Make that AVG. Alrighty, so it calculated the average. If this is your class, then you know the test average is 87.67 or whatever. I'm going to trust that that's true. If you wanted to calculate the average and the sum of a list, can you do that with one call? Yeah, because there's a sum command. There's a sum built-in function. So you could just do this. Total is equal to sum of the scores. And an average, you know, is equal to the total divided by the length of the scores. For some reason, there's no average built-in function. You could write one. They both work just fine. This is what I would ask you on an exam, just to prove that you understand the concept of looping in order to add up everything. Right? This is too easy. But in real code, you'd use that. You know, if they give you a function and it's easier to write, you ought to take advantage of it. So, things to remember. Define a list with square brackets, braces, I never remember what I'm going to call them. Each element separated by commas inside the braces. If you don't put any elements in the braces, it's called an empty list. Functions for lists. Well, the built-in functions are just length. I'm going to use capital L, meaning that that's the list name, and sum. To loop through a list, for V in L with a for loop. Print V or whatever you were going to do. All right.
Is it the same to loop through a two-dimensional one?
Sort of. Let's see if we can, well, I erased my two-dimensional list. I guess we're going to make it again.
I'll ask because I'm actually still doing something with it.
Okay, yeah, let's do it. Let's do it. Score 2D for two-dimensional is equal, and let's make our list of S1, S2, and S3 again. Now, so for every list in the two-dimensional array, for every value in the list, let's print the value. And then when we're done with that row, let's just print some dashes to show that that was the end of that row. Now, if I played my cards right, that'll print out the list in groups of 3. Bump, 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 bump. That's a. Have I got a goof here? Yeah, thanks. I always mess that up if I start mixing uppercase and lowercase letters. All right, so there it went. Off we went to the races. And if you're not getting the idea of two-dimensional lists, that's okay. If you are, that's even better. What is this statement doing? It's pulling out element by element from the S2D list. And the first element is a list. Then the second element is a list. And then the third element is a list. Once we have our list, we can use the secondary loop to step through it. And if you wanted to write that using, the range statements in the index counters, yeah, you could do that. I'm not going to write it like that, though. That making sense?
Yeah.
Cool.
Can you run it again?
Pardon me?
Can you run it one more time?
Yeah, I didn't run it. Let's run it and see. So S1 equaled those 3 values. That was the first element of our super list. S2 equaled the second 3 values. And S3 equaled the third 3 values. So S1, S2, and S3.
I got a syntax.
Yeah, let me come look. So what if you want to do data entry into a list? If you want to do data entry into a list, you have to have that list defined before you can start adding items to it. You have to have a shopping cart before you can put stuff in the shopping cart. So we're going to make another list. We're just going to call it names. And we're going to make an empty list so that we can ask the user for some names. Do we want to ask them for a fixed number of names, in which case we need a range statement? Or do we just want to let them keep typing in names until they get tired of it? Let's make a fixed number of names first. So for I in range, we're going to get real tired of typing names if I make this number too large. So I'm just going to do for I in range 3. Remember if I said that if you leave off that 0 comma, it starts at 0 anyways. So you know what we could do is make it start at 1 and stop before it gets to 4. Why would I do that rather than counting 0 to 3? Because what if I wanted to display inner name 1, name 2, and name 3? Users don't want to see inner name 0, name 1, and name 2. So I'm just going to start it at 1. Now when you were printing them out, you'd better not do it that way. When I mean printing it out, if you're iterating through the list, you better not start it at 1. Tell you what, just for that purpose, I'm going to go back to doing it at 0 and going up to 3, and then when I print it out, I'll add it up. So let's do that. Name is equal to input, enter name plus, no, end quote, plus the string version of I. I'm messing with this just a little bit. But that's going to print out 0, 1, and 2. But I'm going to make sure that works. And then add that to names. And now I've done something I never liked doing, which is using the same variable name just separated by an S or not. Why do I hate that? Because it's too easy to make a mistake and put an S there or leave off the S when I want it. So I'm going to change that just to, I don't know, N. Not the best. But anyways, now I want to add that on to names. So names.add, I never remember if it's .add or append, so I'm going to make it .add, and if it fails, I'm going to change it. It's append. Thanks. All right, there we go. And now I'm going to print out my list, just so I can see that it worked. I hope this makes sense. The reason why I did this plus stri is because input only accepts one string here. So I can't do that same thing that we do with a print statement where, you know, we print something, quote, comma, you know, where you use commas. You can't use commas inside an input statement to break up things that you want to print as your prompt. So instead I used a plus sign. All right, I was hoping that I would be able to see what's at the bottom. Obviously I can't, so I need to bang my window up there. There we go. Enter name 0. Joe, Bob, and Jack. And it printed them out. What if I didn't want to do this business because this looked a little bit too weird? Well, you know, I think y'all can handle it, but I do want to add a 1 to that. That's a 1, not an L or whatever, so that it'll say name 1, name 2, and name 3. So to do data entry into a list, you declare an empty list first. Then you get an element and append it to the list with l.append. L being the name of the variable that you're using. And that's what we did here. You just keep processing until whatever condition, you know, is done. Now I have a list. I want to build up another list of their favorite foods. Joe, Bob, and Jack's favorite foods. So it's going to be a second list. And it's going to be what's known as a parallel list. A parallel list is when you have 2 or more lists of the same length where the items are thematically linked by their index number. So Jack likes ice cream. Name 0 is Jack. Food 0 is ice cream. Right? And then, I've messed that up, but you get my example. Bob likes, you know, pizza. Then element 1 in the names list could be Bob, and element 1 of the foods list will be pizza. Let's do that again. For I in range 0, 3, I'm going to do it a little bit more old school here than I did this so that, you know, it follows our more traditional. Print, enter the favorite food for end comma names subscript I. Now I goofed in my for statement. I didn't type I here. So go back and put an I there. I goofed that statement. I forgot the I. Don't type that comment. Now we need to do an input. But I goofed because I also did not declare my empty list. If I want to declare my empty list as foods, what would my syntax be? Foods equals what? How do I make an empty list? Square brackets. There's another way, but that's the way that makes the most sense to me. So let's get the food. F is equal to input, and let's add it to foods. F.append, excuse me, foods.append F. Let me scroll this up now. So at this point, we have 2 lists, names and foods. These are parallel lists, meaning they have the same length, and each element is linked by index value. So that food 0 is for name 0, foods 1 is for names 1, foods 2 is for names 2. And we could prove that to ourselves by just printing them out. For I in range 0, 3, and by the way, I should not be hard coding that 3. That should be the length of the list. Because what if later on we make it so that the user can enter 5 names or 7 names? We wouldn't want to have to go and change all those 3s to 5s or 7s. What if we make it to where they can enter as many names as they want until they type quit? Well, then there's no way in advance we would know. But anyways, so let's print out their name and their fave food. Names, subscript I, foods, subscript I. Now you really can't use a for value in list syntax for this, because we have to have an index counter in order to process a parallel list. Why do I say that? Because if we did for v in names, we wouldn't have an index counter in order to pull out the foods for that specific position. So there are times when you can't use this clean little syntax here, specifically for processing parallel lists. Again, I can't see it. Bless you. All right, enter name 1, Abe, Bob, and Carol. Enter the favorite food for Abe, ice cream, pizza, and whatever, pie. So Abe likes ice cream, Bob likes pizza, and Carol likes pie. I hope that makes sense. I hope the idea of parallel lists makes sense. You really already have the idea, because if you were coming up with, final grades for a list of students, you have the student name in one column, and you have their final grades in another column, and they're linked by their position, right? If Alice is the first person in the list and she made an A, then, they're linked by their position, their row in the spreadsheet. Same idea, except we start counting with row 0. Alrighty, now the sheet here, the textbook showed using the in method to check to see if something is in the list. The way that the syntax is if value in list name. So, if ice cream is in the foods list, print yay, ice cream for ice cream. Else, print no ice cream, crazy talk. That's how you check for an element in a list. But all that does is determine if it actually is in the list. If you want the index value of it, there's a different method. Like if you care whether ice cream is element 0, 1, or 2, you'd use a different function. Technically a method because it's attached to the string class. If a method is just a function that's attached to data. All right, so enter name 1. Abe, Bob, Carol, their favorite foods. Pizza, ice cream, and pie. And it says, yay, ice cream for ice cream. So that worked. If I ran it again, and I'm not going to run it a second time, although you should, and didn't type in ice cream, it would say no ice cream, crazy talk. So this searches a list to find it. So that's another thing about lists. Up here, I was mentioning important things about lists. Let's add a few more if you're taking the same notes I am. This is the one that says things to remember. L.append E appends E to the list, E being an element. If E in list checks to see if E is in the list. Let's see what else our textbook has to say. So the easiest way to traverse a list is with the for value in list syntax, which is fine if you're not doing parallel lists. And again, this is showing the way where you have a singular and a plural. That's great, but then it causes typos. I guarantee. So then you can iterate it by using an index value for I in range to the length of the list. Now this one is updating every element of the list. It's taking the array and every value of it's being doubled. You would not be able to do this with this style list because you can't change the values of cheese. If you do cheese is equal to cheese times 2, I mean it's a string so that's stupid, it would not work. In order to change the values of the list you have to have the index value. So that's called traversing the list when you're iterating through it. If the list is empty, it doesn't do anything. So if we define an empty list like names and then we use a for loop to try to iterate through that empty list, it's not going to get into it to begin with. So you can use plus sign to concatenate lists just like you can strings. And here's their example. We've done that. A is equal to 1, 2, and 3. B is equal to 4, 5, and 6. C is equal to A plus B. And then when you print it out, you get 1, 2, 3, 4, 5, 6. List slices. This is imperative. This is incredibly important. Slicing lets you take a certain number of elements out of the list. Like, do you remember we had our scores list and it had 9 elements? What if you only want the first 2 elements out of the list? Or let's get just the first 2 names. F2 for first 2, or heck, first 2 is equal to names starting at position 0 and going up to but not including 2. And then if we print that out, print out first 2, we'll see that it's only the first 2 names that you typed in. What if you want the last element of the list? Other languages don't support this. This is a quirk of Python. But you can do this. Last is equal to names and then put in the negative subscript there. -1 means the last. -2 means the second to the last. -3 means the third to the last. You can do that too. So this is what's known as slicing. And I'm not entirely sure your textbook calls it that. It better, because everybody else in the universe who does Python programming does. So starting at 0, at position 0, up to but not including 2. So that's the first 2 elements. Let's get the third and the fourth score out of the scores list. So if I want to get the third score, what index is that?
2.
Yeah, it's 2. It's not 3 because that would be the 4th element. So zero-based indexing. So we're going to do, I don't know, just come up with a variable name. X, because I'm not feeling creative. X is equal to the scores starting at position 0. Nope, not 0. 2 because that's the third element. And if I want the list to be 2 elements long, then I would just add 2 to that and go 2 to 4. That's my way of figuring out how long the list is going to be. This is a list starting at 0 and it's too long because the difference between 0 and 2 is 2. This is an element. This starts at index value 2. And 4 minus 2 is 2, so we know it's also going to be 2 items long. What if we want elements 6, 7, and 8? I'm going to say elements at index 6, 7, and 8, so we don't have to do that -1 trick. So x is equal to scores. Now what's my first number going to be? It's going to be index what, because I just specified it. Yeah, if I was doing elements 6, 7, and 8, the 6th and 7th and the 8th elements, but I specified the index value, so I'm going to go ahead and say 6. I'm sorry for that -1 business. And then what am I going to go out to? Well, how long is the list? How many elements do we want? Well, if we counted how many are here, how many are here? 3. So 6 plus 3 is 9. I hope that didn't mess you up why we had to do 2 there. Does that make sense? Because if you have a list that looks like this, 1, 2, or Joe, Bob, Jack, Alice, Sue, Carol, Sam, and then you want the third and the fourth elements. Well, that's the first element, that's the second element, that's the third element, and that's the fourth element. And then if we put their index values underneath them, 0, 1, 2, 3, 4, 5, and 6. So if we want the third and the fourth element, well, the third element is that one, which is index 2. The fourth element is index 3. But here I said, let's get the elements at index 6 and 7 and 8, so we would have just started at 6. Does that make sense? Cool. All right. That's called slicing. If you leave a number off,
Sorry.
pardon me. Yeah.
Let's say third and fourth. Isn't it supposed to be 3 then? Instead of 4?
Well, the third and the fourth scores are just like the third and the fourth names. What's the third name in this list?
Jack.
Jack. Okay, and what's his index number?
2.
So does that make sense?
No, what about the other one, the fourth one?
Well, how long is this list going to be? It's going to be 2 elements long. So we got to start at 2 and then get 2 more. So the way you read this is starting at 2 and go up to, but not including that one. So we're starting at Jack, if we were getting the third and fourth of this one. And that's 2. Get number 2, get number 3, and then stop before you get to 4. So that gets you the second and the third one. Weird, I know, but you get used to it. You can do this. I want the first 4 elements. That's 0, 1, 2, and 3. Index values of 0, 1, and 2, and 3. So you just leave off a number, it means go to 0. Y is equal to scores, starting at position 4 and going all the way to the end. Like that. That's a handy little syntax. Why? Because otherwise you'd have to specify, the length of the list there.
So if you put 0, it'll just look through the whole list, or it'll go through the whole list?
I think I know what you're asking. What if you did this? Z is equal to scores like that?
Yeah.
That is the entire list. And that's an incredibly important way of doing that, because if you want a copy of the list, that's what you do. Z is now a copy of the original list. And sometimes you do want to get a copy. Sometimes you want your original data and then you want to manipulate it somehow, but you also want to preserve your original. So you make a copy of it first, and then you do all your changes to Z, and you still have your original scores list. Excellent point. Excellent point. We're about done. All right, if you want to delete an element from a list, there's a couple of ways you can do it. Of course, there has to be more than one way. There's the remove command, which is a method of the list class, and then there's del, which is not. So delete the first element from the scores list. Scores.remove element 0. Let's make sure that we got that right. Nope. I done did that wrong. Delete scores element 0. That's if you know the index number. If you don't, like if we want to delete Bob from our list of names, now that's actually going to mess everything up because we'll no longer have parallel lists. Okay, so let's do it with scores. Say if somebody has a 100, but you wanted to find that 100 and delete it. Scores.remove 100. Delete the first score of 100. That's what that means. And by the way, it blows up if there are no 100s. So you could put that in if statement. If 100 is in the scores, remove it. And if you made it a while loop, it would go and it would remove all of the scores. So we'll protect that on our comments, and we'll make a Dropbox and we'll be done. So del list at index I deletes the value at I from the list. L.remove value removes V from the list. And I know that they showed a third one. There's also a replace, L.replace, and you could replace all of the occurrences of 100 with zeros if you wanted to wipe out all those 100s and replace them rather than remove them. All right, that's about enough.